So, what have we learned from the example? We learned that there are equations with one unknown in which the exact solution could not be determined, but could be approximated using numerical approach. In the case of our example, it is possible, meaning it is allowed. No, it is possible to determine values of theta wherein our f theta is closer to 0. But note that it is very much impossible to determine a numerical value of theta for which f of theta is exactly 0, meaning all we can do in numerical approach is to approximate and find values closer to 0 but not exactly uh, the values that cause f of theta to become 0. Thus, when solving an equation numerically, one has to select the desired accuracy of the solution. That is, to select appropriate range of acceptable approximation for the solution. So in the example, an analytical approach completely differs numerical approach in solving. In the numerical approach, an approximate solution is first identified, followed by numerical procedures to make the assumption much accurate. Okay, so this first we made an assumption, and then from that assumption, we uh, we use analytical approach not to solve for the uh, approximation. Just like in the example, we plotted the graph of f of x and we figure out an approximation to the solution. Then from the graph, we find our first approximation and we figured out that it is still far from what we are looking for. So we pick another approximation based on the previous approximation that we had. So since 2.4 is still far from 0 in our example, we selected a new approximation 2.43 based on this previous data that we have. So it is basically just like an initial value is identified, then we iterate until we can acquire a much accurate approximation. That is why using a computer to do numerical procedure is very beneficial in terms of time, speed, and accuracy since it will do repetitive tasks. Okay. So basically there are two methods in solving equations numerically. So equations with one variable. First is the bracketing method and the second is the open methods. So we will first discuss the bracketing method shown in this figure. So in the bracketing method, an interval that includes the solution is identified. This interval's endpoints A and B are the upper bound and the lower bound. Then, by using numerical solution, this interval gets smaller and smaller, or the endpoint gets closer and closer to each other until the approximated solution is found based on your desired accuracy. On the other hand, the open methods, as shown in this figure, um, an estimated guess of the solution is first identified. Unlike the bracketing method requires an initial interval, while the open method requires an initial guess, one initial guess for the solution. The initial guess for the solution should be close to the actual solution. And then by using numerical scheme, a better and more accurate values of the solutions are calculated. So the bracketing method always converges, meaning um, bracketing method guarantees to find an appropriate approximate solution, unlike the open method. However, open method is much efficient. Each method has algorithm that will be discussed on the subsequent lecture videos, and you will be assigned a task to implement them on your own. But for the meantime, since numerical solutions are not precisely exact, there is a need in estimating errors. Thus, we will be discussing this topic first in the next lecture video. So that is all for this lecture video, and see you on the next one.